Trigonometry is the study of triangles. What do we know so far? We know that the sum of angles in a triangle is equal to 180 degrees. Number 2 is Pythagorean's theorem. A squared plus b squared is equal to c squared. Now we'll introduce a third concept called SOHCAHTOA. What does this stand for? It stands for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Now what does this mean? Let's do an example. Say we have a triangle here, and the square symbol means it's 90 degrees in this corner, and this is always the case. Say this is 32 degrees. This is A, C, and B. C is the hypotenuse. A is opposite, and B is adjacent. Now why is A opposite? Because it's opposite of the angle we have, 32 degrees. Now, let's use this formula. If we're given A is equal to 5, and we want to find the hypotenuse. So we can plug it in. Sine 32 degrees equal to 5 divided by c. We can rearrange, so c sine 32 equal to 5, and c is equal to 5 divided by sine 32. Plug this in on a calculator, you'll get approximately 9.44. Now, so this is 9.44. Let's say we want to find this angle x. Now we don't need to use SOHCAHTOA. We could use one of these two principles, but just for a case of example. And now you'll notice adjacent and opposite are switched around because we're going relative to angle x. So now we want to use cosine equals adjacent over hypotenuse. Yep, because we have this one and this one. So cos of x is equal to 5 over 9.44. And there's a button on your calculator that looks like cos of -1. And inside this function, you want to put 5 over 9.44. And if you plug this into your calculator, you'll get approximately 58 degrees. And this lines up with our triangle because 90 plus 32 plus 58 is equal to 180, which is correct. Next, let's look at something called special triangles. The first one is like this: 1, 1, square root 2. This is 45 degrees, 45 degrees. Second triangle is 3, 1, degrees, this is 30 degrees, this is 90 degrees. And we kind of just have to memorize these triangles. The next thing is sine and cosine waves. So if we draw this out like this, sine and cosine have a nice pattern. So this is sine of x, 0, 90 degrees, 180 degrees, 270, and 360. So on a sine wave, it looks starts off at 0, comes up to 1 at 90 degrees, goes back to 0 at 180, negative 1 at 270, and 0 at 360. Then if you were to continue on this graph, you would repeat in the same fashion. Next, we draw out cosine of x. It's very similar to sine. So we got 90 degrees, 180, 270, 360. And for cos, it starts off at 1, goes to 0 at 90, negative 1 at 180, 0 at 270, and 1 at 360. Now, the graph for tangent is much different. So we still got 1, negative 1, and then here we have negative 45 degrees, 45 degrees, and here we got negative 90 degrees and 90 degrees. Now for tangent, it's going to be negative 1 and 1 at 45 degrees, 0 at 0. But at negative 90 and 90, we're going to have this asymptote here, which means tangent is undefined. If we draw this out, it's going to look something like that. So it'll never reach negative 90 degrees or 90 degrees, but it's going to get very close to it. All of these functions, or special triangles, you just have to memorize. So if you see a triangle, for example, this one, and it's 60 degree, 30 degree, you don't have to use a calculator. You can just know that this side's 1, this is 3, this is square root 2. Another thing involves the trigonometry. Say you have 4 angles here, right? This is 0, 90 degrees, 180 degrees, 270 degrees. And so anything in this first quadrant, right here, all of the trig functions are positive. In the second quadrant, only sine is positive. Third quadrant, only tan is positive. And fourth, only cos. So the acronym for this is all smelly tom cats. You can use a different acronym if you want, but basically means, tells you where each trig function is positive. So this one, all positive, only sine is positive, only tan positive, only cosine positive. Last thing is converting to radians. Radians is a very common measurement, an alternative for degrees. So say you have 180 degrees, you want to multiply by pi over 180, and you'll get pi radians. Similarly, if you have 2 pi radians, you multiply by 180 over pi, so you want the pi's to cancel out, or the degrees to cancel out. So you want them on the top and bottom, top and bottom. And so this equals 360 degrees. In general, 0 degrees equals 0 radians, 90 degrees equals pi over 2 radians, and 180 degrees equals pi radians, 270 degrees equals 3 pi over 2 radians, and 360 degrees is equal to 2 pi radians.